Hey guys, this lesson is going to be on the properties of logarithms. This PDF is attached to the Google Classroom where this video was also attached. So you can either print this guided notes worksheet out and take your notes alongside the typed up notes, or if you prefer, or if it's just easier, you can follow along and copy everything down in your notebook. So you may want to press pause occasionally so you can copy down the things that are typed already, but these properties right over here I'm going to rewrite anyway as I talk through them. So whatever you need to do, if you have to hit pause, then do so, and when you're ready you can come back and join us. Alright, so this is section 4 and it's called properties of logarithms. Before this we worked on exponential functions and we talked about the relationship between exponentials and logarithms. Hopefully we all remember what that relationship is. The objective of this section is to use properties of logarithms, and we'll use them for a lot of different things. Essential understanding: logarithms and exponents have corresponding properties. Now, if you remember some properties of exponents, that will come in very handy when we're dealing with properties of logarithms because of this link. For example, if I were multiplying something like x to the second power times x to the third power, what does that equal? If you said x to the fifth power, then you're correct. X to the fifth power is our answer because when you're multiplying like bases, meaning the bases match, you add your exponents. How about when you have to do an example like x to the second power raised to the third power? What does that equal? If you said x to the sixth, then you were right. When we are raising something to a power and then we raise that whole thing to a power, you multiply your exponents. Another property we have is when we divide like bases. What do you get when you divide x to the 12th power by x to the 4th power? If you said x to the 8th power, then you're right. When you divide, you end up subtracting your exponents. So you're going to see a link, especially highlighting with this right over here, this right over here. We're not going to get too into it, but you'll notice a connection. So these properties of logarithms we have that we're focusing on today are the product property, quotient property, and power property. Each side is either the condensed or simplified side, and then the other side is the expanded side. So over here, this one on the left is your condensed or your simplified side. And this side, over here on the right is the expanded side. The product property states that when you have a log of any base of a product, here they're using m and n as lowercase letters. You could have anything you want. We can have smiley face times heart, okay? Not the nicest heart, sorry. We can expand that, or we can be given the expanded side and then we can simplify that to get log base b of smiley face. Now it was a product multiplication similar to this over here, plus, so this whole thing plus log base b of heart. This right here is the expanded side, and this right here is our simplified or condensed side. Quotient property. The quotient property will give you something similar, log base b of a quotient. Now that quotient could be something like star divided by a flower, could be anything, whatever it might be. And when you have division, it's going to become subtraction. So that will become log base b of star, sorry, I'm squeezing it over here, minus log base b of flower. Third, oh, and sorry, this is our simplified or condensed side, and this right here is our expanded side. Sometimes you could take it even further after you expand a bit. You could sometimes use another property, which is our third one right over here, which is the power property. So if the power property, what that's going to tell us is if we have log base b of, running out of things over here, rectangle raised to the swirly power, well, that equals the swirly power comes out front and it becomes a normal sized symbol, log base b of rectangle, and then these are connected by multiplication. Again, this side here is our condensed side, and this side here is our expanded side. We're going to practice this first, and then as we practice and get comfortable with it, we could have better conversations about it. So let's just practice these properties to begin. What is each expression written as, what is each expression written as a single logarithm? So right over here, we have our first example. It's subtraction. So which property are we going to use on this one? We're going to use the quotient property. That means I'm going to rewrite this as log base 4 of 32 divided by 2. From here, I can take this a little bit further. What could I do next? I can write this as log base 4 of 16. What could I do next? How else can I rewrite the number 16? Since log is the inverse operation of exponentials, it would really benefit me greatly if I can rewrite this 16 as this base right here, that number to a power. Can I write 16 as 4 raised to a power? 4 to the second. Now I could also simplify even further. If I really you're done, if you're following the directions right at this step. All it says is write it as a single logarithm. Sure, you're finished. But what are we? We're a bunch of overachievers. So we're going to go a little bit further. Sorry. So we're going to use our power property now. And the power property tells me this little power up here, log base 4 of 4. This power out here can come out front as a regular size 2. Now, how do you read logs? The way you read log, this part right over here, is you say the base 4. 4 to what power is 4? And what's the answer to that question? 4 to what power is 4? 4 to the first power is 4. So we're left with 2 times 1. Our final answer is 2. Now there are 2, sorry, right there. There's more than one way to do this. That's just one example. Let's do the next one. We have powers out front, and we want to put them away. So when you were a kid, your mom told you, put your toys away. You had to put your toys away back up on the shelf, okay? So when we're condensing and cleaning up, we got to put them away. Right now we're all expanded, our toys are all out. So that 6 will become x to the 6th power plus log base 2 of y to the 5th power. In the next step, I want to use the which property? We want to use the product property. So this will become log base 2 of x to the 6th times, not x, y to the 5th. really, you're done. It's a single logarithm. How do you know it's a single logarithm? Well, how many is single? Single is 1. So do I have 1 log? Yeah. I can't really do much more with this right now, so we'll leave it as it is. So there we go. Here we have another example. You have the same base. Oh, and that's important too. If you notice they were all base B, that means that the bases have to match or you can't do anything, okay? What property are we going to use first? We're going to use product property, log base 4 of 5x times 3x. Then clean that up a little bit. I know we're really a single logarithm already, but let's make it a little nicer. What is 5 times 3? What is x times x? So we're good. You can leave it like that. Beautiful. Love it. Next example, I'm going to start by putting away the toys. Okay, power property. So we'll get log base 4 of 6 to the second. Maybe you jumped right to what 6 to the second is. What is 6 to the second power? That's 36 minus log base 4 of 9. Subtraction means we're going to use which property? Quotient property. (36) divided by 9, well, that's not so bad. I shouldn't be afraid. I can simplify that fairly easily. This looks familiar. 4 to what power is 4? We took it a little bit far, but better to be an overachiever. On this next page, we're going the other way. What is each logarithm expanded? So right now, these are already condensed and we want to expand them. These also already have sort of invisible parentheses around them. Maybe you want to put those there to help you out a little bit. In this case, it is important because this example would be different than if I had, say, log base 3 of 9x to the 5th. So it is important to know, is the 5 on the x only or is it on the whole package over there? So these are not the same thing. So you really want to pay attention to that. If there's no parentheses, it's only on the 5. I'm sorry, it's only on the x, whereas here it's on both of them. So we could break it up into a few steps. It's up to you. I do think it's better to get into a habit of sort of doing as much as possible at once so that it gets easier for you to expand and simplify. I have a product between 4 and x, and then I have a quotient between where the x leaves off and the y picks up. Products turn into the log of one thing plus the log of another thing. I think I used heart and smiley face before. So log 4 plus log x minus, division turns to minus, log y. And that's it. Nothing else we can do here. I guess you could expand if you really, really wanted to expand further. I guess we could go and say that this is log of 2 to the second plus log x minus log y, and then bring that power out front, take your toys out, 2 times log 2 plus log x minus log y. Now, on a question where you could have more than one right answer, all 3 of these are correct. So it's probably something important to keep in mind. Over here, I'm going to squeeze this example down a little lower. My settings are a little funny, so if you can't see that too well, let's zoom in a smidge. And that, I have the contrast up really high to help with the sharpness, but that's x to the 4th, that's a base 9, and that's 729. So I will have log base 9 of x to the 4, but that 4 is going to go out front and multiply. Power property in action. Subtract, because division, that's your quotient property. Log, gotta write log every time. When you're applying these properties, you put log on all the pieces where you separate with the subtraction and addition, okay? Log base 9 of 729, but this number looks pretty familiar to me. It looks like it might be able to be written as 9 to a power. So this part over here is more or less done. Maybe you need to bust out your calculator to check what that is. Log base 9. Sorry, my 9's and G's start to look like. But I know 9 to the second is 81. I hope you remember that. Now, what if I multiply that by another 9? Well, there you go, 729. So 729 could be rewritten as 9 to the third power. But if I want to feed two birds with one stone, I can take this 3 and bring it out front with that power property. And we're more or less done. If you want the parentheses, you can put them there. Actually, I do see one more thing I can do. This right over here. Log base 9 of 9. What can I do with that log base 9 of 9? Remember how we read log. 9, the base, to what power is 9, the thing we're taking the log of? And what's the answer to that? 1. So it's 3 times 1 now, which is just 3. So we could write our answer as 4 log base 9 of x minus 3. Keep in mind it's important that this x is not in a parenthesis with the x minus 3. So you might want to write it like this for good habit, or maybe you want to turn it around, negative 3 plus log base 9 of x. So you don't accidentally combine the x and the negative 3, but also you don't want to combine the negative 3 and the 4 because they're not like terms because this is attached to the log. So this answer is right, this answer is right, all good. Next, we have another example here, log base 3 of 250 minus log base 3 of 37. Now you're really I'm totally cut off. You're really sort of finished, but again, I'm extra. So what multiplies to give me 250? 125 and 2 minus log base 3 of 37. 125 can be rewritten as a number to a power. I like to call these moments swopportunity, a good swopportunity. We're going to swap 125 out for something else raised to a power. It's especially handy if it were a 3 to a power. In this case, it's not 3 to a power, but 3 is involved. Do you remember what 125 can be rewritten as? 125 could be rewritten as 5 to the third power. While I'm at it, I'm going to turn that multiplication into addition with my product property. It's log base 3 of 2 minus the log base 3 of 37. And that 3 can come out front, so my final answer is 3 times log base 3 of 5 plus log base 3 of 2 minus log base 3 of 37. So we got that answer right over there. I'll color coordinate at the end to neaten this all up for us. Last but not least, log base 3 of 9, x to the 5th, log base 3 of, what do you think I should write first? 9 plus, now I would write log base 3 of x. I could put to the 5th, but let's be a little better than that. Think smarter, not harder. Let's bring that 5 out front already. Beautiful. And can I clean anything else up? What about log base 3 of 9? 3 to what power is 9? 2. 2 plus 5 log base 3 of x. Now we're done. Hope you enjoyed. So that was just some practice and lesson on expanding logarithms and simplifying or condensing logarithms. And the next lesson in a separate video will be a lesson about the change of base formula.